Well, guys, we have officially made it to Module 8. This last module is going to cover the last two Georgia standards for geometric and spatial reasoning. It's going to be standards 7 and 8. Just a reminder of the math timeline. Over the next 2 years, we're going to be participating in professional learning with the goal of understanding these new standards. So it will not be until school year 2023 that we will begin with full implementation of the standards with updated assessments. I always like to include something about the importance of math or something that's inspiring or speaks to our hearts. And this module is no different, but I did do something a little different. Go ahead and scan the QR code and watch the video. It just is a quick little video about the importance of math. It's actually a promo for a company, but I want you guys to focus on the students at the beginning of the video versus the students at the end of the video, specifically their language. It feeds into the whole concept of having a growth mindset that we've been talking about through the last 8 modules. So I think it'll be a little tidbit of inspiration as we wind down this school year. Geometric and spatial reasoning is our geometry standard. It's going to deal with polygons, points, lines, line segments, rays, angles, perpendicular lines, area, and perimeter. For geometric and spatial reasoning, I included the learning progression for grades K through 12. It really does a good job of, for those 2 standards and shapes and properties and geometric measurements, of showing you what students will specifically be coming to you knowing, also what the expectation will be for the following grade level. So for GSR7, I only included the first part of the document. So GSR7 is going to be looking at investigating the concept of angles and angle measurements to estimate the measure of the angles. I wanted to note with this part of the standard, you have fewer evidence of student learning than in some of the other standards. But I do want you to read over them because what they do have there is very explicit. Particularly the age and developmentally appropriate area, it explains specifically what students should have the opportunity to do and what students are expected and not expected to know at this grade level, which is going to be exceptionally helpful. And we'll kind of cover that a little more in depth as we dig into the standard. As we're looking at this document, I want to particularly point out GSR8.1 because the example they give specifically deals with lines of symmetry. But when you dig in and read the standard, you will see that you're just not looking for lines of symmetry to identify shapes. You're also going to be looking at parallel and perpendicular lines, which falls in line with part of the standards that we've been currently teaching. Again, that evidence of student learning, that's going to be your bread and butter. That's going to be the area that you're really going to want to spend a lot of time digging into the standards. It's very explicit on expectations, which is going to be so helpful when we get ready to create curriculum maps and deciding how we're going to teach these standards in this content. All right, let's jump in. Geometric and spatial reasoning 7. Investigate the concepts of angles and angle measurement to estimate and measure angles. So 7.1 is the first expectation of this standard, and it is recognize angles as geometric shapes formed when 2 rays share a common endpoint. Draw right, acute, and obtuse angles based on the relationship of angle measures to 90 degrees. So this is a really great example of an activity that you could do with students where they're looking at these angles and they're deciding if they're acute, obtuse, or right. One of the things that I've done in the past that I'm sure you guys have seen on Pinterest is using electrical tape or painter's tape and creating angles on the table and having the students do the same thing. You could even take it a step further when you start talking about specific degrees. As like an activity extension. But go ahead and scan this QR code to see a really great digital quick check tool. So students could use this in a rotation during small group math, or you could do it on the board as like a culminating activity of a lesson. It's just like a little quiz that takes them through where they look at different angles, and they decide, is it acute, obtuse, or right? So standard 7 expectation 2 is measure angles in reference to circle with the center at the common endpoint of 2 rays. Determine an angle's measure in relation to the 360 degrees in a circle through division or as a missing factor problem. This is going to be a little more in-depth than kind of where we've been with our geometry standards. It's more specific in what students will actually be able to do. One of the things that I want to note about the fundamentals for this expectation is that it talks about angles should be introduced with non-standard tools, such as pattern blocks, unit angles, and/or wedges. So prior to introducing protractors. So protractors do not need to be introduced until students understand identifying angle measures using non-traditional tools. I really like this shift in the standard because it's going to give students a chance to really explore and more conceptually understand geometry. The example included for Standard 7 Expectations 2 is the one pulled directly from the standards document, which is students can place 4 squares around the center of a circle. Since there are 360 degrees in a circle, 360 divided by 4 equals 90. So each square has 90-degree angles. I really love this hands-on example, and it could also be used in reverse to introduce students to other shapes and angle measures. So it's a really good, and it's a real world applicable activity. So for example, we've got all these roundabouts in the Statesboro area now. That would be a really great image to pull up of a roundabout and then to talk about the angle measures that the roads create. It also could then bring the conversation of parallel and perpendicular lines. And it really, the way we are going to be teaching these geometry standards is going to be very cool, in my opinion, because we're going to really be able to incorporate a lot of real world examples, and hopefully that's going to give students a deeper understanding of the content. So the last standard is Geometric Spatial Reasoning Standard 8. Identify and draw geometric objects, classify polygons based on properties, and solve problems involving area and perimeter of rectangular figures. Standard 8 Expectation 1 is explore, investigate, and draw points, lines, line segments, rays, angles, right, acute, obtuse, perpendicular lines, parallel lines, and lines of symmetry. Identify these in two-dimensional figures. So with this expectation, students are really going to be digging in to shapes and what are those attributes of them? What are those things that can help you explain the specific shape you're looking at? They need to be, one of the big words that's used repeatedly is students should investigate. So for example, it says students should investigate lines of symmetry in 2D figures. It also talks about the intent of this learning objective is for students to investigate these specific properties like perpendicular line segments, lines of symmetry, etc., as they work with those 2D figures. The whole point, I say again, is for students to be investigating, students to be working through looking at those specific properties or attributes of these shapes and lines. That's what's going to give them the conceptual understanding. That's what's going to give them a deeper meaning. And as always, being sure that we are including really good real-world problems. So some of the specific terminology students need with Standard 8 Expectation 1 is right angles, acute angle, obtuse angle, perpendicular line. Those are going to be words that are going to be expectations. With those words, they are going to be defining and identifying things like lines of symmetry. So the example included is showing lines of symmetry in quadrilaterals. And so one of the ways that we want students to be able to explain these quadrilaterals is by their lines of symmetry, also their angle measures. So one of the things I love to use while teaching lines of symmetry is origami. So students really learn quickly how precise you need to be to create these shapes, and it really helps them make a concrete connection to the perfection of a line of symmetry. So I included a little QR code here that will take you to an origami activity where they can make a Yoda. My students have done this the past 2 years and they've really enjoyed it, especially with the resurgence of Star Wars. But what I love about it is that as we're doing it, I'm pausing the video and we're specifically talking about those lines of symmetry. We're talking about the shapes that we're creating, the lines that we see in our paper. I even had one student last year, after we were finished making it, make a second one specifically so he could unfold it and we could look at the paper and see all the different lines. And we talked about which lines were intersecting, which ones were parallel, which were perpendicular. And it really gave the students a buy-in because it was an activity that they were interested in, but it was also something that they connected with and they understood and they remembered. So creating those engaging and memorable experiences, especially when you're doing something like geometry, is super helpful with having them retain the information so that they can understand it to move on to the next parts of the standard. Standard 8 Expectation 2 is classify, compare, and contrast polygons based on lines of symmetry, the presence or absence of parallel or perpendicular line segments, or the presence or absence of angles of a specified size and based on side lengths. So this is where you're taking what you've learned in Expectation 1 and students are actually applying it. With Expectation 2, there is a lot of terminology for the students. For example, it includes that a polygon is a closed figure with at least 3 straight sides and angles. A polygon is regular only when all sides are equal and all angles are equal. A polygon is irregular when all sides are not equal or all angles are not equal. It also includes isosceles triangle, equilateral triangle, scaling triangle, and right triangle, an acute triangle, obtuse triangle, and those are going to be terms that students are going to be expected to know, which is something that that's already been embedded in part of our standards. So that part of it, the terminology, isn't going to be a huge shift. But one of the words that I mentioned before that's again mentioned in this expectation is investigate. So students are investigating those lines of symmetry. Students are using investigation to classify shapes based on properties. Those are going to be the key to students understanding this expectation. So the whole goal is for them to investigate lines of symmetry and parallel and perpendicular lines in those 2D figures as a property of them. So that is a way to classify the shape. So students need to look at polygons like triangles, quadrilaterals, including kites, trapezoids, rectangles, squares, rhombuses, and other parallelograms and pentagons to identify those lines of symmetry as a classification tool, but also looking at those parallel and perpendicular lines and tying all that back to acute, obtuse, and right angles, as well as identifying and classifying triangles. Standard 8 Expectation 3. Solve problems involving area and perimeter of composite rectangles involving a whole number with known side lengths. So I included this little graphic that just talks about area being inside the shape, whereas perimeter is on the outside of the shape. I really like the change in vocab here. Before we have talked about finding the area of rectilinear figures. They have changed that to composite rectangles. So we will specifically be looking at composite rectangles. And so that is going to be a little bit of a terminology shift moving forward. So with this example, you can see the purple shape is a composite rectangle. It kind of looks like an L turned sideways. A big change in the standard is going to be that students are not going to be expected to find unknown side lengths while exploring composite rectangles. So that means that students will have all side lengths identified for them, and they will be able to solve it without finding out unknown side lengths. I think that is huge. It's definitely going to aid in their understanding a little more deeply of this standard. I love this activity, or excuse me, I love this expectation for activities like garden planning in the spring, or they could plan their dream backyard with a swimming pool. All those are different ways that you can apply this standard of area and perimeter and make it engaging for students. Definitely putting a real world spin on it. I work at Stilson, and that is one of the more rural end of the county, and so a lot of my students have at-home gardens. So that's something that they connect to. So when we created our gardens this year, we specifically created gardens with composite rectangles in mind. So that was kind of one of the stipulations. They couldn't have just we called them boring gardens. They couldn't have just a plain rectangular garden. They had to add some depth to it. And that was a way to get students engaged and involved. They were very into this project, and they were applying the skills of finding area and perimeter of the shapes, which was really cool. And we were able to tie it to our ecosystem science standard, which was even better. Okay, guys, so this resource page is going to include the learning progressions, summary of changes, and those K-8 standards. I included page numbers that will specifically apply to us in 4th grade. I would definitely make sure you're printing out copies of these and digging in as we move forward next school year and continue our professional learning for these standards. Okay, so some major takeaways. Relevant activities are going to keep students engaged. Geometry should be hands-on. Get out the graph paper and pencils. Pull out those plastic shapes. Get students engaged and involved. Use wedges and pattern blocks to reinforce angle measures before protractors. Students will not have to find missing side lengths for area. Whoop, whoop. And as always, if you have any questions, please feel free to email me at leads@bullockschools.org. Thank you guys so much for watching these modules and working through. I hope you guys are excited about the change and the shift in standards. The depth of conceptual understanding that's being pushed forward with these new standards and the explicit instructions for us, I think is going to be hugely helpful to our students, but also us as educators. I'm really enjoying looking over it and seeing the examples and the terminologies. Also, thank you guys so much for everything that you've sent in and completed for this course. We can't wait to dig in and kind of compile some resources together for our 4th grade math teachers. The last thing that I'm going to ask you to do is actually 2 things. Please try to find any resources you might have for teaching these standards that we've gone over and include those in a Google Doc. It can be linked in that Google Doc, or you can include the actual activity there. And then also, please ask any questions you might have so that we can try to get back to you guys and hopefully answer those questions. I hope that I was able to go into detail and kind of fill in some blanks, but I also know it's really hard until you start living the standards and teaching the standards in your class. It's really hard to kind of know what questions you have. So as you're kind of experimenting with them going into next school year, please still feel free to reach out to me and let me know if you have any questions or concerns. Again, thank you guys so much.